Hello everyone, today I'm going to talk about homework 10 question 1. The first question is asked about the Poisson process. And we know that Poisson process have three properties. The first property is that the number of n t1 to t2 equals to k in the interval t1 to t2 of length t2 minus t1 is a Poisson random variable with parameter lambda t, which the probability of nt1 to t2 equals to k equals to e to the power of lambda t multiply lambda t to the power of k over factorial k. And if the interval t1 and t2 and t3 and t4 are non-overlapping, the random variable nt1, t2, and nt3, t4 are independent. And at the time moment t1, there is no more than one Poisson point. Using the point ti, we form the stochastic process xt equals to n0 to t1. So we need to calculate it. We know that the probability mass is equals to the given function. So the pxt equals to k is equals to e to the power of minus lambda t multiply lambda t to the power of k over factorial k, and the mean of expectation of xt equals to lambda t. The autocorrelation of t1 and t2 equals to lambda square t1 t2 plus lambda multiply the minimum number of t1 t2, and the autocovariance equals to lambda t lambda squared t1 t2 multiply the lambda multiply minimum t1 t2 minus lambda t1 multiply lambda t2, which equals to lambda multiply minimum t1 t2. And then the second one is asked about the Poisson increment process, and the yt equals to x t plus epsilon minus xt over epsilon, where xt is the Poisson process. And after I found in the lecture notes, the probability mass is the probability of yt equals to n over epsilon equals to e to the power of minus lambda epsilon multiply lambda e to the power of n over factorial n, and the mean is lambda. The autocorrelation of t1 t2 equals to lambda square when t1 t2 t1 absolute value of t1 minus t2 is larger than epsilon, and it equals, and the r autocorrelation equals to lambda square plus lambda over epsilon minus lambda multiply the absolute value of t1 minus t2 over epsilon square when absolute value of t1 minus t2 is less than epsilon, and the correlation is has the close relation between the autocorrelation, which equals to 0 when t1 absolute value of t1 minus t2 is larger than epsilon, and it equals to lambda over epsilon minus lambda multiply absolute value of t1 minus t2 over epsilon square when t1 t2 absolute value of it is less than epsilon. So if we want to know the point impulse process, which is equals to the following graph, it has some several impulse in a specific time value. It can be defined as zt equals to derivative of xt based on t, where xt is a Poisson process. The probability mass of it has no definition. and the mean of it is equals to lambda t, because zt can be defined as xt of the third derivative of xt based on t, and we know the expectation of xt is equals to lambda t, so we can easily get the expectation of zt equals to lambda, as the autocorrelation of it is equals to lambda squared plus lambda multiply delta t1 minus t2. The autocovariance of it is equals to lambda delta t1 minus t2. The semi-random telegraph signal xt is defined on Poisson points again, and the number n t1 t2 of points is equals to k in the interval t1 t2 is a Poisson random variable with parameter lambda t. Therefore, the probability of mass function is equals to the first one, and xt is equals to 1 when k is even in time interval 0 to t, and xt is equals to -1 when k is odd in time interval 0 to t. Therefore, in mass function, probability x equals to 1 is equals to e to the power of minus lambda t multiplied by e lambda t plus e to the minus lambda t over 2, and pxt equals to -1 equals to e to the power of minus xt multiply e lambda t minus e to the power of minus xt over 2, and the autocorrelation of t1 t2 is equals to e to the power of minus 2 lambda multiply absolute value of t1 minus t2, and autocovariance t1 t2 is equals to e to the power of minus 2 lambda multiply absolute value of t1 minus t2 minus e to the power of minus 2 lambda multiply t1 plus t2. So if we want to calculate the probability of random walk, we can imitate the process by toss a fair coin in n times, and k is the number of heads in n toss. So x nt equals to ks minus n minus ks, and the first order probability mass is equals to probability xt equals to x nt minus num x is a combination of n over n plus r over 2 multiply 1 over o to the power of n. The mean is equals to 0, and the autocorrelation is minus is the minimum n and n multiply x squared. The autocorrelation covariance is equals to minimum n and n multiply x to the power of 3. The Wiener process is the Wt equals to the limit of xt when t equals to the limit of 0, and n equals to the limit of positive infinity. When xt is a random walk, the density function is the following question, is following equation, and the mean is equals to expectation of wt, and we know wt is limit of xt, and the mean of expectation of xt is equal to 0, therefore the mean of it equals to 0.2, and the autocorrelation of one process is equals to minus T1, T2 alpha, and the autocovariance of T1, T2 is minimum value of T1, T2 multiply alpha. That's the question 1.